Good day everyone. I Tripti Mishra welcome you in NCERT Science Mantra. Today we are going to discuss exercise solution of class 10th chapter number 1 chemical reaction and equation. This is part 2nd in which I will explain question number 11 to question number 20. Question number 11 is, why are decomposition reactions called the opposite of combination reactions? Write equations for these reactions. Decomposition reaction combination reactions की opposite क्यों कहलाती हैं? So as we know that decomposition means decompose. Decompose means breakdown of a compound in the two or more substances. And also for breaking down the compound we need the energy. This energy can be used in the form of heat or light or electricity. So here there is the use of energy and breakdown of substance. Opposite to the decomposition reaction, in the combination reaction, combination means combine. Combine means in which two or more smaller substances combine together and give a new substance. And also in this there is the release of energy. So that both of the reactions are just opposite to each other. So what we should write here? Decomposition reactions are those in which a compound breaks down to form two or more substances. These reactions require a source of energy to proceed. Thus, they are the exact opposite of combination reactions in which two or more substances combine to give a new substance with the release of energy. Now here equations are given for decomposition reaction. A and B. AB, substance AB, we will provide it energy, then it will divide into A plus B. For example, molecule of water H2O in liquid, if we go through it by electrolysis, then it will divide in the hydrogen and oxygen gases. Hydrogen gas and oxygen, two smaller compounds, hydrogen gas and oxygen gas. Opposite to the decomposition reaction, in the combination reaction, two smaller substance combines together, likewise A plus B. A plus B combine together and forms AB, and also energy is released. For example, 2H2 plus O2, hydrogen and oxygen combines and gives water plus energy. So that is the difference. Totally opposite. Decomposition reactions are totally opposite to the combination reactions. Question number 12 is, write one equation each for decomposition reactions where energy is supplied in the form of heat, light or electricity. So we have to give the equation for each form: heat, then light and then electricity. Three ways for completing decomposition reaction. So answer is A. For A, thermal. Thermal means where the energy we are supplying in the form of heat. So example is the thermal decomposition of ferrous sulfate, FeSO4. Then as we will provide it, warm it, then it will give ferric oxide Fe2O3 plus sulfur dioxide SO2 plus sulfur trioxide SO3. So this is the example of thermal decomposition in which ferrous sulfate divides into the ferric oxide, sulfur dioxide and sulfur trioxide. Another equation will be, we will write for decomposition by light. Decomposition by light. For example, 2AgCl, silver chloride, in the presence of sunlight, it will divide into the silver and chlorine gas. So that is the example of decomposition by light. Now, decomposition by electricity. In this, we will go through by the electrolysis. For example, Al2O3 aluminium oxide divides into the aluminium and oxygen gas. That is the example of decomposition by electricity. Here also you can give the example of the decomposition of water, where water decomposes and gives hydrogen and oxygen gases. Question number 13 is, what is the difference between displacement and double displacement reactions? Write equations for these reactions. So we have to write the difference between displacement and double displacement reaction. We know that in the displacement reactions, more reactive metal displaces the less reactive metal or element to form a compound. Okay, so more reactive element displaces less reactive element. For example, if we have a more reactive element A and it will react with Bx, a compound of element B, then A is more reactive than B. Then A will displace B from its compound. So it will give Ax plus B, where A is more reactive than B. Then instead of this, it is the displacement reaction. Then instead of the displacement reaction, double displacement reaction, two atoms or a group of atoms switch places to form new compound. For example, AB plus CD gives, they will exchange their ions and they will form AD plus BC or CB. For example, displacement reaction is copper sulfate plus zinc. We know that zinc is more reactive than copper, so it will displace the copper from its compound, copper sulfate. Okay, then it will form zinc sulfate plus copper. Then example for double displacement reaction, sodium sulfate plus barium chloride, barium sulfate plus sodium chloride. Here we will get the white precipitate due to the formation of this barium sulfate. Question number 14 is, in the refining of silver, the recovery of silver nitrate solution involved displacement of copper metal. Write down the reaction involved. Here we have to write only the reaction equation. So during the refining of silver, silver is found in the form of silver nitrate. Then we will use copper. Then copper is more reactive than silver. So it will displace the silver from its compound and forms copper nitrate plus silver. And here we will get the silver. So this is the reaction 2AgNO3 AQ. AQ means solution in water. Aqueous solution. Copper solid, it will give copper nitrate plus 2Ag, silver. Question number 15 is, what do you mean by precipitation reaction? Explain by giving examples. Then precipitation reactions means precipitation reaction means the reaction in which the insoluble solid or that insoluble solid is called a precipitate is formed is called a precipitation reaction. For example, sodium carbonate Na2CO3 plus calcium chloride CaCl2, if we react with them their aqueous solutions, then we will get calcium carbonate and sodium chloride. So here we will get the calcium carbonate as a insoluble solid or we can say as the precipitate. That's why this is a precipitation reaction. In this reaction, calcium carbonate is obtained as a precipitate, hence it is a precipitation reaction. Another example of precipitation reaction is sodium sulfate Na2SO4 plus barium chloride BaCl2. They will make barium sulfate, white precipitate of barium sulfate plus 2 NaCl. So here we will get the precipitate of barium sulfate, white precipitate. That's why that is also the precipitation reaction. Question number 16 is, explain the following in terms of gain or loss of oxygen with two examples each, oxidation and reduction. So first we will explain about the oxidation. Oxidation means gain of oxygen. Okay, so for this we have to give two examples, carbon dioxide plus hydrogen. As we will react carbon dioxide with the hydrogen, it will give carbon monoxide plus water. Here carbon dioxide is losing the oxygen and hydrogen is getting the oxygen. So hydrogen is getting the oxygen and converting to the water. That's why hydrogen is oxidized here, and there is the oxidation of hydrogen. Then another example, 2 copper plus oxygen, it will give 2 CuO, copper oxide. Copper is gaining the oxygen, that's why that is the example of oxidation reaction. In equation 1, hydrogen is oxidized to water, and in equation 2, copper is oxidized to copper oxide. Then B is reduction. B is reduction. So now we will discuss reduction. Reduction means loss of oxygen. Loss of oxygen. So in this, for example, carbon dioxide plus hydrogen, then there is carbon dioxide will lose the oxygen and convert to carbon monoxide. So here there is the reduction of carbon dioxide, and that's why it is the reduction reaction of carbon dioxide. Plus hydrogen will change to H2O, so there is the oxidation of hydrogen. Oxidation of hydrogen and reduction of carbon dioxide. Likewise same, copper oxide is reacted with hydrogen gas, then copper oxide will lose the oxygen and convert to the copper. So here it is also the reduction of copper oxide. So here we can say in first equation, carbon dioxide is reduced to carbon monoxide, and equation 2, copper oxide is reduced to copper. Question number 17 is, a shiny brown colored element X on heating in air becomes black in color. Name the element X and the black colored compound form. So first here we should focus about shiny brown colored element X, and on heating in air it becomes black in color. So here brown colored element is copper and black colored compound which is formed is copper oxide, CuO. When it reacts with oxygen and heat is provided, during the reaction heat is provided, then copper reacts with oxygen and forms copper oxide which is black in color. So here we can write X is copper, and the black colored compound formed here is copper oxide, CuO. The equation of the reaction involved on heating copper is given below. 2Cu plus O2 gives 2CuO. Question number 18 is, why do we apply paint on iron articles? We know that iron articles, if they are exposed to the moisture, they will react with the moisture and convert to the rust. That process is called rusting. So for preventing the rusting, so many methods are used. One of the method is painting, or we can say to apply the paint. So iron articles are painted because it prevents from rusting. When painted, the contact of iron articles from moisture and air is cut off, hence rusting is prevented. Their presence is essential for rusting to take place. Question number 19 is, oil and fat containing food items are flushed with nitrogen. Why? As we have studied in the process, that food is rancidity of the food. In the process of rancidity, oil and fats are going to be oxidized, and so that they create some foul smell and stale taste. That process is called rusting, and flushing with nitrogen removes the oxygen, and it stops or prevent the rancidity. That's why we are using the flushing of nitrogen to prevent the rancidity. So what we should write here? Nitrogen is an inert gas and does not easily react with these substances. On the other hand, oxygen reacts with food substances and makes them rancid. Thus, bags used in packing food items are flushed with nitrogen gas to remove oxygen inside the pack. When oxygen is not present inside the pack, rancidity of oil and fat containing food items is avoided. Our last question, question number 20 is, explain the following terms with one example each. First is corrosion and second is rancidity. So first we will discuss here corrosion. Corrosion is the process where materials, usually metals, deteriorate as a result of chemical reaction with air, moisture, chemicals, etc. That is called the process of corrosion. For example, iron in the presence of moisture react with oxygen to form hydrated iron oxide. Equation we can write here: 4Fe plus 3O2 plus n number of water molecules. It will forms 2Fe2O3 and H2O, that is hydrated iron oxide, and it is the rust, and the process is called rusting and also corrosion we can say. This hydrated iron oxide is rust. Then now we will discuss about rancidity. Is the process of oxidation of fats and oils that can be easily noticed by the change in taste and smell is known as rancidity. For example, the taste and smell of butter changes when kept for long. Rancidity can be avoided by storing food in airtight containers, storing food in refrigerators, adding antioxidants, and storing food in an environment of nitrogen, or we can say nitrogen flushing. So that are the methods by which we can stop or prevent rancidity. So now we have completed all questions of exercise of chapter number 1, class 10th. If it is beneficial for you, please like the video and share the video with your friends. Subscribe this YouTube channel. I have also prepared other videos for this chapter. For that videos link I have provided in description box. You can go to the description box and watch that videos also. Thank you.